Alright, in this video we are going to look at story graphs. So we will be matching stories to the correct graph. We'll be working at drawing our own graph and writing our own story given the graph. So first we're going to practice just matching a story to a graph. So I actually want to have you try this one first. So read your three options, either A, B, or C, and pick which one you think matches this graph. Make sure you pay attention to our axes every time you look at a graph because they're going to change. So this is distance from home over time. So go ahead and pause the video and select your answer. Okay, so if we read through our options here, option A says Tom took his dog for a walk to the park. It set off slowly, then increased. So this is one of the things I'm paying attention to, is that speed. And then I analyze my graph here. So this first part of the graph, if I look at this chunk, in a little bit of time, so a second chunk, there's a lot more time. So in a little bit of time, I cover quite a bit of distance, which makes me think that this is a fast speed. Okay, and in this part, I cover only this little bit of distance, but I take all this time to do it. So this represents a slow pace here, right? I'm not covering a lot of distance, but I am taking a lot of time to do that. Where here, I didn't take a lot of time, and I covered a lot of distance. So this doesn't match here, slow and then faster, so that's how I eliminate option A. Okay. B, Tom rode his bike east. Okay, we can't tell direction on a map, so that doesn't do anything for us. This is not a map, it's a graph. Up a steep hill, which still doesn't tell me very much. After a while, the slope eased off at the top and raced down the other side. So this tells me Tom's on the other side of the hill, so he's not home. Where this graph shows me he's returning home here at the end. Distance from home is 0 here and 0 here. So my story, Tom started at home and he ends at home. In this one, he doesn't. So B is incorrect. Okay, which means C is our correct answer, but let's look at why. So he went for a jog. At the end of the road, he ran into a friend, so his pace went slower. So he's jogging, and then he slows, so that matches that speed we looked at the beginning. Okay, when he left his friend, he went quickly back home. So again, this is a faster speed. It's a steeper slope here, and he returns home. So everything in the story matches what's going on in the graph. So C is the correct answer there. Okay. I want you to pause the video and try another one and flash play when you're ready to see the answer. So if we look here, we're talking about distance again. We don't know distance from what, just distance overall over time. So option A says a car is traveling at a speed limit and then gradually slows. So I would say this part of the graph shows a constant speed. It's a straight line, so we're covering that same amount of distance. So that matches. Gradually slows down, which means I'm going to be covering less distance. So this is slowing down here. And stops. So if I'm stopped, my distance isn't changing. So this does represent we're stopped, right? Our distance isn't increasing anymore. Then accelerates again, so my distance is going to start to increase. So A looks promising, but let's look at our other options. A car is traveling at a constant rate. Yes. Curves to the right, that doesn't do anything, so except for maybe we're slowed down while we're going to a curve, right? This is showing that we're getting slower. And the car continues straight. So this does not represent straight. This represents the car has to be stopped because my distance isn't changing. So again, the fact that this doesn't show that the car has stopped, B cannot be the correct answer. B is trying to describe this like it's a map again, right? A curve, straight, and then go to the left. This is a graph, not a map. So if you selected B, make sure you're thinking about that. C, the car is traveling slowly at first, then travels at a constant speed before accelerating. Again, we don't have that stop in the story. This isn't really very slow here. This is faster than it is here, so that kind of got that backwards in the story also. So A is the correct answer. It's the only one that talked about a stop sign. All right, one more of matching the story to the graph. Okay, if we look at our options here, a roller coaster is stopped at a station and then takes off down a large hill. So one thing that's tricky about this graph is 0 is right here, okay, and we're talking about speed this time, not distance. So is my speed at 0 in the graph? No, it's starting at some speed. So the fact that this story says that I was stopped at the beginning kind of makes me think like it's not going to work out. Okay, so I'm going to cross that one off. We can come back and look at other details, but right there, I think it's probably not right. B, a roller coaster climbs up a large hill at a constant rate. So in the last graph, when we had distance, constant rate looked like this because the distance was constantly increasing. But now that we've changed to speed, a constant rate means our speed is constant, which means we have a straight line this way. This doesn't represent stopped on a speed time graph. A straight line horizontally on a distance time graph represents you're stopped because that means your distance isn't moving. But this means we're all staying at whatever speed this is, whether it's 5 miles an hour or 10 miles an hour. It is constant. When it gets to the top, it speeds down. So if we're going down a roller coaster, our speed goes up, right? That's our speed goes up. And then when it gets to the top, it speeds down, passes through a tunnel, and goes up another hill. So went down. Normally when you get to the bottom, you go up a hill, your speed's going to come down a little bit, and then going through that tunnel. Okay, it doesn't really show going up another hill, but for everything else matches. Okay, so that B is a possibility. C, a roller coaster is unloading passengers. Ooh, if we are unloading passengers, what should our speed be? I hope it is 0, which does not match our graph. So B is the correct answer there. Okay. Next thing when we work with story graphs is if I give you a story, one of the skills you need to be able to do is draw the graph. Okay, and this is something that just comes with practice. So I am going to have you try this one first to see what you get, and then play through the video to see how I draw mine. All right, a bus accelerates from a stop, so I'm just going to highlight some keywords. Stop, and I have a speed, so if I'm stopping, I know my speed has to come back to 0, right? 0 miles per hour. Then drives at a constant speed until it approaches its next stop. So then they stop again, loads people, and then accelerates away. So from a stop, so the bus starts at a stop here, so that's my first stop. We're starting from a stop, we're starting at 0, and it's accelerating, which my speed is increasing. Then I'm driving at a constant speed, so if I reach the speed limit, let's say, I don't know, maybe it's 45 miles per hour. You don't have to add these numbers, I'm just doing that to help my story. Constant speed is staying at that 45 miles an hour until it approaches another stop. So, whoop, it's going to slow down. It has to touch it back down here because my speed has to be 0. So it needs to touch that x-axis again to show a speed of 0. And it's unloading passengers, so time is passing. So we are staying at this 0 miles per hour for a little bit, and then we accelerate away again. Okay. Now there are some variables in my graph. Right? Accelerate, if you want to add a little curve like this instead of a straight line, that's fine, or vice versa. Okay, we haven't really talked about the different curves. And that same thing could happen here. If you don't want a straight line for when you're slowing down, or when you're speeding up. A lot of times speeding up, if we think about realistically, it's a little slower at first and then we gradually go up. So a lot of times you'll see that curve like this can show accelerating too. It doesn't have to be that straight line. Okay. And same thing, slowing down if you want to do the fall off. That is up to you. Sometimes I do it, sometimes I don't. Important thing is you start at 0. You have this constant speed, so a straight line here. You touch back, you have this waiting time, and then accelerating off again. Okay? So pause the video and try to draw a picture or a graph of this story. All right, so my dad drove me to school this morning. He accelerated and then drove for 10 minutes at about 30 miles per hour. We then slowed to stop at a stoplight for 2 minutes. Then we got on the highway and drove at 50 miles per hour for 20 minutes. So he's accelerating and gets to about 30 miles per hour for 10 minutes. Then, so I'm going to go back and change this a little bit. I'm going to have him accelerate a little faster. 10 minutes. Then slows to a stop sign for 2 minutes. So if this is my 10 minutes, 2 minutes is probably just this little bit. Then I'm going to get on the highway. So if this is 30 miles per hour, I've got to go higher than that. And for 20 minutes, should be double that. So that's kind of how my graph goes. Again, if you want to add numbers, you can. 30, 50. You don't have to. Just try to make it match. Meaning if this is 10 minutes, my 2 minutes should be smaller. My 20 minutes should be larger. That kind of thing. So now we are going to do the opposite. I'm going to give you the graph, and I want you to try to write a story. And when we do this, it's really helpful to kind of break each piece of the graph up. So I've already done that for you. But realize sometimes you might have to do that yourself. Right? Something's happening at A, then something else is happening at part B, something else is happening at part C. We're talking about a car trip, and we're talking about speed over time. So see if you come up with a story, and then play through to hear mine. So this is my story. I said the car accelerates from a stop, right? We started at 0, so make sure you talked about car being at a stop. And our speed is increasing, which means we are accelerating or speeding up. So those would be some key things I'd be looking for in part A if I was grading this on homework or a test. B, the car reached the speed limit and continued at a constant speed. Okay, I'm looking at this constant speed, or maybe you talked about the speed limit being 25 miles an hour. Okay, something where you're telling me that we're driving at the same speed, that 25 miles an hour. Okay, if you want to be even more specific, you could tell me how long you guys are driving at that speed. C, the car is beginning to accelerate to get on the highway. So they weren't stopped here. They're on some side road, and now they're speeding up again. So I said they're going to get on the highway. Okay, but something about accelerating is really what I would be looking for there. Okay. So let's try another one. Notice now our graph has 4 parts. We've got A, B, C, and D. We're talking about distance from home. So we changed from speed to distance, so those graphs are a little different, over time. So pause the video and try to write me a story. So this is my story. I said Jill's leaving her home. So distance from home was 0. So at some point Jill, or somebody, you don't have to use Jill, is at her home, and I said she's walking to school. Okay, maybe you said they were biking, maybe you said they were going to a friend's house. Either way, they needed to start at home and be going somewhere. Right? They left their house. B, they're going back towards their home because our distance from our home is going down. But they didn't go all the way home. So to put this into my story, I said she realized she dropped her house keys, turns back to find them. So she turns around, finds her house keys, and now C, She thinks she's going to be late for school, so she starts to run. So I threw that in there because this is not a very steep slope, and this is steeper, which means this is a faster pace. Right? So here I said she was walking, then here I said she was running, to kind of get that into my story, the change of pace. And then D, her distance isn't changing, so I said she's in her seat at school, which means she's not moving. Our distance isn't changing.